One more time, my friends. Most of you went off and played on Mayfest on Friday. Listen, the reasons for virtual memory, very important. Do not forget these. You can't be a computer engineer unless you remember these. They are, no, I'm joking. The reasons for virtual memory are to allow a process to be bigger than the size of physical memory. If somebody said to you, sorry, your program doesn't fit, we only have 2 gigabytes of main memory, you're like, wait a minute, man, I've got this data, I've got this program, I need to run it. Are you telling me I can't run it? Yeah, we only have 2 gigabytes. Go out, you need 12, go spend a whole lot more money. Oh, no, the main board doesn't hold 12. Oh my goodness, I've got a 300 gigabyte disk, for Pete's sakes, can't I just use the disk? No, 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 you're not allowed to have anything bigger than main memory. What kind of world is that? Ridiculous. Okay, so virtual memory allows us to have our code and data on disk, but be using it as part of the program. So it allows main memory to not be the limit, disk to be the limit of the size of your code and data set. Raise your hand if you disagree. The world has got some pretty big programs and some pretty big data sets. Do you disagree? Go visit Google. Go visit Yahoo. Go visit, Amazon. You'll find there's some enormous programs and enormous data sets. You can't limit them to the size of physical memory. That's the first question. So it allows us to get bigger. That's a really great benefit of virtual memory. But that's just the tiny little tip of the iceberg. Listen to this one. Virtual memory allows me and you and you and you and you and you and you to be in memory at the same time and running our processes at the same time, either sharing one CPU or each of us on our own CPUs. We've got multi-core now. So if I got 8 cores, I'd love to run 8 processes or 8 threads. But if they can't be in memory at the same time, oh, your thread's turn, bring it in from disk. Thanks, you're done, put it back on disk. Your thread has a turn, bring it in from disk. Forget it. We have to be in memory at the same time. Okay, so to be in memory at the same time, to share memory in any reasonable way, we have to have virtual memory. Virtual memory allows us to share without interference. I have no knowledge of you. I think all of memory is mine. Oh, I get all of memory. And you think all of memory is yours. We all think it all belongs to us. Actually, it's being shared. A few pages are for you, a few pages are for you, a few pages for me. Who's doing that clever memory management? Operating system, of course, is providing the illusion of all of memory for you and as big as the disk. Wow! Oh, this is great, man. It's not that way, but it provides the illusion. That's why we use the word virtual. Now, if you don't want those benefits, then you must love embedded processors because they don't do virtual memory. You must love small toy systems because if you don't like those benefits, you don't want multi-users, multitasking, you just want small little things. That's fine. There's a world of plenty of things that run on small little embedded programs, but there's a lot of things that need big Kojima monstrous memory space and they need the ability to share an expensive machine. Okay, so now if you want to do those things, we need virtual memory. But the price for virtual memory is translating from virtual address to physical address. That translation, doggone it, it's so slow. What are we going to do? Hey, let's cache it. Yeah, let's speed it up with a TLB. Okay, now we're talking. But the TLB first and then cache next requires hit, and they both better be pretty slow or it won't fit in a clock cycle, or I have to shishko and stretch out my clock cycle and slow everybody down. Oh no, we don't want that. Right? So you understand? You following my logic here? Okay, so we want virtual memory, but that requires translation. Translation ended up going to main memory with this big table unless you can cache a portion of it and have a high hit rate, but it's still hard to shill. So now we're saying, after having said all that, how about if we don't do it hard to shill? How about if we do it in parallel? Okay, so here we go. Here's parallel. Don't forget translation is a little small pyramid consisting of what? Consisting of what? A cache in static RAM we hope we hit, and if not, the rest of the full page table, not the rest, the full page table in dynamic RAM, main memory, which will be slow. Okay? So when we say translation, there's a little pyramid here consisting of TLB and then page table. Everybody know that? Yeah, that's the meaning of this box. Okay. But the point is, if I can give my virtual address to cache, I don't need any translation. Yeah, it's there. Yeah, it's not. I hit or I miss. If I hit, give it. If I miss, hey, Kardesh, you got that physical address yet? Send it off to main memory. I don't have it. Okay. All right, so we're allowed now to be doing two things in parallel. We're looking here while we're translating here. Right? Now, if we have a hit here and a hit here, this will pop out fast and this will pop out fast. But who cares? That's bullshit. We cancel that. Hit, thanks, on to the next one. So it doesn't matter that I go to main memory. If I have a hit here, it's okay. Bullshit fair. It's going to get canceled. We got what we needed and on we go. Do you understand? Okay, so the idea of parallelizing it seems great. But can we do it? Now, finally, now that I've motivated, now that I've explained the system, can we do it? Is this even possible? Is there some kind of a Pembe Ruya here, or a Yalan, or a Hile, or a trick? Oh, it's so tempting. Oh, come parallel. Don't do it in RDC. Oh, come. But can we do it? Is it realistic to give a virtual address to cache, but give a physical address to main memory? Birdaka, wait a minute. What does this contain, please? Yeah, the subset of this, right? Whatever ones of these I frequently use, I'm supposed to put them here. Okay, wait a minute. Now, if it's located at address 2,458,000 here, and the value stored there is blah, 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 can I store blah, 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 but at a different place here and be able to find it? You know, something a little bit strange there. All right, let's ask ourselves the question. Virtual address cache would only require the address translation on a miss. You wouldn't require translation on a hit. But, there's a big but here. Let's see what it says here. You go read that. Hopefully I've got you interested in the problem. Sounds great. The Chakishma Sizlik, which virtual memory ensured, has now gone away, hasn't it? Because your virtual address 27 and my virtual address 27 are not the same thing. At your 27, you want some data in your program. At 27, I want some code in my program. Make it 28 so it's divisible by 4. Yeah, they're looking for completely different things. But if you send your 28 to cache and have a hit, you know what you might get? Mine. You might get mine. Okay, all right. So that's called alias.